Hi dear, today we'll see the mirror formula. Okay, mirror formula and its magnification and a few problems. Okay, numericals. Okay, so what is mirror formula? It gives a relationship between the object distance, image distance, and focal length of a spherical mirror. So you know that why we have to study this mirror formula. You know by the ray diagram you know where the image will appear, right? The image is formed in the convex mirror or in the concave mirror, you know where the image will be formed, but exactly at what position it will be formed, at what place it will be formed, at what distance from the pole, where the image will be, or how big the image will be, or how small the image will be. So you have to get a clear values about this, where the image is formed and how large it is, how small it is. So we are going to we are going to find it using the mirror formula. Okay, so it's a relationship between the object distance, image distance from the pole, and the focal length. You know that 1 by, so the mirror formula is 1 by f equals to 1 by v plus 1 by u. Okay, this can also be written as 2 by r. Why 2 by r? Because you know that f equals to r by 2, right? Focal length is equals to half of the radius of curvature, right? So r by 2, so 1 by f can be written as 2 by r. That is a reciprocal of this. Okay, so we can write the mirror formula as 2 by r equals to 1 by v plus 1 by u. You know that, remember that always u means you'll usually use the initial, right? Initial means if you place object, then only you will get the image. So keep this u as a object distance from the pole, v is your image distance from the pole, f you know focal length. So what is the focal length? Means distance between the focus point and the pole, and you know that r is the radius of curvature. Clear? So what is mirror formula? 1 by f equals to 1 by v plus 1 by u. It can also be written as 2 by r equals to 1 by v plus 1 by u. Okay, so from this we can find where the image will be formed, or where the object to be placed to get the image at this place. So what will be its focal length, everything you can, once you know two values, you can find the other one. Okay, so next one is your linear magnification produced by the spherical mirrors. Magnifications we use it, it may be, the image may be a same as the size of the object, or it may be enlarged, or it may be diminished. Okay, so how will you say whether the object is enlarged or diminished? So we'll compare with the original object, size of the object, right? Comparison, nothing but your ratio, right? So always we'll compare the image formed with the size of the object, that is your height of the object. Okay, so it gives it's a ratio of the height of the image to the height of the object. This is the original size, height of the object. With this we are going to compare. Okay, so magnification is represented by the small m, and h is your height of the object, and h dash is your height of the image. So we have totally three cases in that. How the what will be the magnification value? There are three cases. So when the object image height and the object height are equal, then what is your, you know that magnification equals to image height by object height. So if both are same, for example 5 centimeter 5 centimeter means that is equals to 1. So your m value magnification is 1. Okay, when the image is same as the size of that object. So what will be the next other possibilities? Two possibilities are there. So when the height of the image is greater than the height of the object, and another one is height of the image is less than the height of the object. So when the height of the object is greater than the height of the image is greater than the height of the object, means you will get magnification will be greater than 1. That is when the image is magnified, you can see for the words magnified, enlarged, or size of the object is greater than the size of the object. So size of the image is greater than the size of the object. That means magnification equals to h dash by h, nothing but the height of the image by height of the object. That is equals to, if the height of the image is greater, 10 by 5 means that is equals to 2. So which is nothing but greater than 1. Okay, magnification is greater than 1. So in case when the image is smaller than the height of the object, the image is smaller than the object, so we will get m less than 1. So m equals h dash by h, that is equals to image is smaller. So 5 divided by 2 means that is equals to what? 1 by 2, that is equal to 0.5. It is less than 1. M is less than 1. Nothing but magnification is less than 1. So these are the 3 cases. Now they will be asking when the m equals to 1. When is m greater than 1? When m will be less than 1. So you have to compare with the height of the image with the height of the object. Okay. Next, this linear magnification can also be related with the object distance and the image distance. So you can write the magnification in terms of m equals to minus v by u. Okay, you know that always u is positive, right? sorry, u is negative. So you will not usually have the negative integers in the denominator. So it has to be removed, right? So we'll put minus v by u. Okay. To cancel this negative sign in the denominator, multiply both numerator and denominator by negative sign. So you'll get minus v by u. Okay. We'll move to the numericals. Few numericals. So the radius of the curvature of the spherical mirror is 20 centimeter. Radius of curvature. That means r they are given. What is its focal length? So what is given? R equals to 20 centimeter. To find what we have to find, we are supposed to find focal length. Okay. We know that the relationship between f and r, right? F equals to focal length is half of the radius of curvature, r divided by 2. So what is your r? 20. 20 divided by 2 equals to 10. So f equals to 10 centimeter. Clear? Next. Find the focal length of the convex mirror whose radius of curvature is 32 centimeter. What is given? Radius of curvature is 32 centimeter given. To find the focal length, so f is equals to question mark, and we know that the relationship between f and r. F equals to r by 2. For r equals to 32 by 2, that is equals to 1 balance 1 16 centimeter. So your focal length is 16 centimeter. Clear? Next one. An object is placed at 25 centimeter in front of a concave mirror of focal length 15 centimeter. At what distance from the mirror should be placed to obtain a sharp image? At what distance what distance from the mirror should be placed at what distance from the mirror screen should be placed, from the mirror screen should be placed to obtain a sharp image. Okay, so what is given? The object is placed in front of the 25 centimeter in front of the concave mirror. So we are going to use the concave mirror. Object distance means what? It is represented by u. Okay, u is always what? Whether it is a concave mirror or convex mirror, u is always negative, right? So minus 25 centimeter. While writing the given itself, we'll put the signs. Okay, f. Since it is a concave mirror, so it is a concave mirror, right? So your focal length will be, this is your pole, and for example this is your radius, then your f will be here. So you have to use the Cartesian conversion, right? So f is placed in the minus side of the x, right? So minus 15 centimeter. So at what distance from the mirror screen should be placed to obtain a sharp image? To get an image where the image will be fall, so that if we keep the screen there, you can get a clear image. Okay, so we have to find the distance of the image from the pole. So they are given U, F, and they asked for the V. So what is the relationship between this V, F, and U and all? You know that 1 by F equals to 1 by V plus 1 by U. So they asked for the 1 by U. So keep the 1 by U V here. So this 1 by U will move to this, transport to this side. So it becomes minus 1 by U. So already 1 by F is there. So 1 by V equals to 1 by F minus 1 by U. Correct? So what is the F value? Already we have given, it is 15 centimeters. So 1 by 15 minus, what is U value? Minus 25 centimeters. So 1 by minus 25. So how to solve this? That is equals to, so since it is a fraction, we cannot subtract directly. So we have to make the denominator common denominator. So what is the, so for that we have to take LCM. What is the LCM between 15 and 25? 15 and 25. What is the LCM? 5, 3, again 5, 3. So your LCM is 5, 5s are 25, 25 into 3, 75. So we have to make the denominator into a 75. So here we have to remove this negative sign also. So here we are going to multiply it by 3 is there, 15, 5 3s are 15, 15 is there, by which number it has to multiply? 5. So 5. Denominator you are going to multiply by minus 3, sorry 5, minus 5. So here denominator you are going to multiply by minus 5 means numerator also you have to multiply by minus 5. Minus 1 by minus 25. To convert into 75 we need to multiply by, so 5 is 25, remaining 3. So you have to multiply by minus 3. Here you are multiplying by minus 3 means here also you have to multiply by minus 3. That is equals to minus 5 by 75 minus 3 by 75. Okay, so you got the common denominator 75 minus 5, minus into minus plus 3. That is equals to what? Minus 2 plus minus plus means you have to subtract only. So minus 5 plus 3 means minus 2 by 75. So you got this. So 1 by V equals to minus 2 by 75. Therefore V equals to, if you take the reciprocal, V equals to minus 75 by 2. That is equals to what? 3 times, balance 1, 15, 7 times, so point remainder 1, so becomes 10, 10 means 5. So minus 37.5. So minus 37.5 centimeter. So it shows that you know that so we got this minus 37.5 centimeter means it always the image will be lie in the negative side of the x-axis. So somewhere it is lie, okay, somewhere it is lying, that is 37.5. So first we will check with the ray diagram. Your focal length is 15 centimeter means what will be your radius? Radius is your 30 centimeter. Okay, your image is, sorry, object is placed at a distance of 25 centimeter from the pole. For example, it's somewhere between here. This is center of curvature, sorry, center of curvature. Somewhere between here at a distance of 25 centimeter object is placed. Okay, so if the object is placed beyond between C and F, center of curvature and focal, means you know that the image will be formed beyond C. Remember the beyond C, real and inverted image. Clear? So now so it is in the left side, negative side of the x-axis. So you got negative minus 37.5. 37.5 will lies. So your center of curvature is up here is 30, and your image will be formed at a distance of 37.5 centimeter. Correct? Got it? Clear on this? So if the image object is placed between C and F, the image will be formed beyond C. Clear on this concept? This is how you have to find the image distance. Clear? Next we'll move to the next question. Convex mirror. Okay, an object is placed at 25 centimeter in front of a convex mirror of radius of curvature 200 centimeter. At what distance from the mirror should a screen be placed to obtain a sharp image? So again they ask for the image distance. So what is the image distance? So what is given? It is given as convex mirror, and your object is placed at a distance of 25 centimeter. So u equals to minus 25. Always u will be minus only, minus 25 centimeter. So r is given. Our radius of curvature is 200 centimeter. Here itself we can find the f also. F equals to r by 2, that is equals to 200 by 2, that is equals to 100 centimeter. Okay. What we have to find? V, that is distance of the image from the pole. Okay. So u is given, f is given, we have to find the v. So what is the relationship between these three things? You know that 1 by f equals to 1 by v plus 1 by u. We need to find 1 by v. So 1 by u will move to this side. So it becomes 1 by f minus 1 by u. Okay. Since it is a convex mirror, what will be this f value? It will be positive only, right? Convex mirror, how it will be? Sorry, I drawn the convex mirror. So, okay. So we are given with the convex mirror, right? So convex mirror means it will be curved outwards. So this is your non-reflecting surface. So this is one, right? So always your f will be here. This is your pole. This is a center of curvature, and f will lies here. It is in the positive side. So f is equals to 100 centimeter positive only. So do the calculation. So 1 by f is 1 by 100 minus 1 by u is minus 25. Okay. So solve this. So what is the, so we need to subtract that. For that we need the common denominators. Here it is different. So take the LCM. What is the LCM between 100 and 25? So 5, 25, again 5, 4, 1, 2, so 5 5s are 25, 25 2s are 50, 50 2s are 100. So 100 only. Your LCM is 100. So already 100 is there. So no need to change this. Keep it as it is. So here you have to change this. Okay, right? So you need 100 here. So 25 must be multiplied by 2 to the 25. So if you have this, you need to multiply by 4, right? So minus 4 here. Here you are multiplying by minus 4 means here also you have to multiply. Why? So make it to plus 100. Okay. That is equals to 1 by 100 minus 4 by 100. That is equals to, you got the common denominator. So 100. Here 1 minus into minus plus 4. That is equals to 5 by 100. Right. That is equals to what? 1 by, if you cancel this, 2, 0, 1 by 20. Okay. So therefore 1 by V equals to 1 by 20. That means V equals to what? 20. Okay, 20 centimeter. So we'll check with the ray diagram whether we got the correct answer. If V equals to 20 centimeter. Okay. So your object is placed in front of the mirror. That means what? They are given some distance. The object is placed in front of the mirror means somewhere between infinity and the pole, right? Infinity and the pole means the object image will be formed between pole and focal length. You know that, right? So your focal length distance is what? 100. So the image will be formed when the object is placed between the infinity and the pole. Image will be formed between the pole and the focal length. So your image, the image distance from the pole is 20 centimeter. Right? 20 centimeter, somewhere between here. Right? So it is in the positive side. You will get a virtual erect image. Remember that? Okay. So your V is at a distance of 20 centimeter. It is in the positive side of the X. So you got V equals to plus 20 centimeter. Clear on this? Next one is a concave mirror produces 3 times magnified real image. 3 times magnified real image of an object placed at 10 centimeter in front of it. Okay, where is the image located? So what is given? It is given it is a concave mirror. So this is your concave mirror. Sorry. So this is your concave mirror. Sorry, this is a concave mirror because it is curved inwards. This is your pole. This is your center of curvature. Okay. So what is given? The concave mirror produces image 3 times the magnified real image. So real image means definitely it will be lie in front of this mirror only. Correct? In front of this mirror. Magnified real image. Magnification, how much time? How much it is? M equals to 3. Why we have put the 3? Why we have put the 3? Because they said real image. Real image means definitely it will be real and inverted, right? So inverted, somewhere it will be lies down the y-axis, below the in the negative side of the y-axis, right? Negative side of the y-axis. So you will get minus 3. Okay. U equals to, U is always negative only. It is placed at, object is placed at 10 centimeter in front of it. So U equals to minus 10 centimeter. Where is the image located? So we have to find the value of V. So M is given, U is given, and we have to find the V. So what is the relationship between these three things? You know that magnification is equals to minus V by U. Okay, remember that. So M equals to minus 3 minus V, we have to find that U is minus 10. Okay, so substitute this, what you will get? You want the value of minus 5 V. So it is in division. When move to this side, it will become multiplication. Minus 3 into minus 10 equals to minus V. Therefore 30 equals to minus V. Therefore V equals to minus 30. V equals to minus 30 centimeter. So minus 30 centimeter. So minus 30 implies that, so it is in the negative side of the x-axis. So you know that when they said real image will be formed in front of the mirror. So it will be somewhere like this. Okay. So this is your real image inverted, and it is in the negative side of the x-axis. So you got minus 30. Clear in this?